Yeah. Now topic is what is parent ion, daughter ion, isotopic peak and base peak. These all are comes in mass spectral topic. So first we have to learn what is mass spectral topic, that is concept of mass spectra, which is also called as principle of mass spectra. In mass spectral lines, we'll get a spectral lines with the help of the common principle is first the principle follows this line. Listen careful here. When a molecule is irradiated with 70 electron volts electron impact beam, this one is important for entrances also. In mass spectra, any given molecule or any sample molecule is irradiated or irradiated with 70 electron volt electron impact beam, then it will absorb some one of the electron and then it is converted, and after absorbing this energy it will lose one more electron. By this it is converted as a radical cation. Okay, radical cation. Here it is following homolytic fission. So it is called, here there is a possibility of a radical cation, which is called M and plus, and so means plus means cation charge as well as radical charge. So only it is called radical cation, which is also termed as a parent ion. Okay. Now it is irradiated with a high amount of energy. Due to this high amount of energy, which has high amount of energy. Okay. Due to high amount of irradiation with high amount of energy, there is a radical cation also associated with high amount of energy. This high amount of energy which leads further fragmentation. Here see. Okay, radical cation is having high energy. Due to this high energy, it is further going to fragmentation, more fragmentation, which leads to formation of just simply M1, M2 fragmented ions. So M1 cation or M2 radical, or may be possibility M1 radical or M2 cation, or M1 radical cation, M2 is a neutral one. Okay. Now again I am repeating. It is a principle of mass spectra, means every mass spectral or sample molecule follows this type of explanation, this type of process. So first molecule is irradiated with 70 electron volt electron impact beam. Then due to this absorption of high amount of energy, this sample molecule also lose one electron, then form a radical cation. This radical cation is associated with high amount of energy. This radical cation also called as parent ion. Due to association of high amount of energy, this radical cation is a, see here, high energy associated with high energy, less stable, and the charge of this parent ion is radical cation. Due to high energy, it is less stable, so it is going further fragmentation. So here see, parent ion, radical cation having high energy, then which further fragmented like M1, M2s. Maybe M1 is cation, M2 is a radical, or vice versa. M1 is radical or M2 is a cation. And one more, M1 radical cation and M2 neutral, means these fragmented ions are having less energy, so these are more stable. And these fragmented ions also called as daughter ions. If we assume this one is a parent and these are called daughter ions. These daughter ions may be cations also there, radicals also there, and radical cations and neutral also possible. Compared to parent ion, these fragmented ions are stable due to having less energy. This is a one topic, what is about parent ion and daughter ion, and sometime it is in exam he will ask like explain principle of mass spectra, or it is also one more question, explain the differences between parent ion, daughter ion. Okay, this is about parent ion, daughter ion. Now based on this nominal explanation, okay, with the help of symbols I explained here. Now I am giving particular example how it is fragmented into daughter ions and how we will get the parent ion. And whatever the ions are there, these will be explained in terms of a M by Z values in the mass spectra. Okay, or M by Z, or we can term it as a M by E here. Mass values can be denoted by M by Z or M by E, means mass per charge, mass per electron. Okay. Now one example I gave here, that is what is mass spectra, means you can explain representation of mass spectra, or you can explain the example of mass spectra of estophenone. See here, first I took sample molecule, that is estophenone. Okay, it is irradiated with 70 electron volts beam. Then it is converted as a radical cation, which is also called parent ion. The value of the radical cation is explained in terms of m by z, means total mass by charge. That is 120. This 120 is nothing but it is a molecular weight of this molecule. Okay, that is m by z of 120. Here mass means molecular weight, by z means it is simply charge. How much charge is there? Whenever the plus or minus, but how much quantity? Only 1. Hence total mass by 1 means again you will get 120. Due to high amount of energy, or due to associated with high energy, this parent ion is going to fragment into smaller ones. Like see here, again it is reassociated, removal of CH3. So only I explained here, minus CH3 radical. Then like M1 M2s. Okay, then it is one more fragmented ion, that is only cation, m by z value 105, and one more fragmented ion, eliminated one, that is a CH3 radical, that is m by z 15. How we are writing this 15 means, in this total 120 I removed CH3. CH3 means hydrogens are 3 and carbon is the 12. So total molecular weight is 15. So I removed 15, m by z 15. So the leftover value is a 105. Okay, m by z is 105. Similarly, I am doing more fragmentation. Again here removal of CO. CO is here neutral. So carbon is the 12, oxygen is the 16. So total m by z value is 28. So remove the 28 from 105. Again you will get one more fragmented, that is the phenyl cation, that is m by z equals to 77. This type fragmentation is most continuously. Okay, first one, neutral molecule which is irradiated with 70 electron volt beam, then it is converted as a parent ion. This parent ion again going to further fragmentation, which gives smaller m by z value containing different smaller ones. These are called as, means these two comes under daughter ions or fragmented ions. Okay, based on these m by z values we are going to draw a mass spectra of estophenone. See here, now this is a mass spectral diagram from 0 to 140. Like these are the m by z values, means mass spectral values, m by z values like 20, 40. So for estophenone we got the peaks at, see here, wherever the m by z value you got in fragmentations or parent ion, that will be give the peak in mass spectra. Means mass spectra nothing but which gives the spectral lines based on the m by z value. So see here, first one parent ion is having how much? 120. So here 120. Next one m by z value 105. So see here 105. And similarly m by z 77, 77. And similarly m by z values like here, one is a 15 and one more is a 28 also I am drawing here. This is a m by z equals to 28. Okay, based on the fragmented m by z values we are going to draw the mass spectra of any given sample molecule. So this is a mass spectra of estophenone. Based on these m by z values we have to draw the lines, and here I drawn so many smaller lines also here. These smaller lines nothing but, here also I can draw one or two smaller lines. These smaller lines is due to isotopic peaks. Isotopic peak nothing but in a given molecule, if the isotopes are there, then the molecular weight will be increased 1 or 2 units. Okay, if it is the first one m by z, there is no molecule. Generally we can calculate the carbon atomic weight, molecular weight is at 12. Okay, so based on the 12 calculation, the m by z value is nothing but this total m value is how much we got here? 120. If the carbon is having one isotope, that is there is a possibility of carbon isotope is C13. If the 12 will be there, you will get a peak at 120 exact m by z value. If in this total molecule, if one carbon is having one isotope, that is the C13, so one of the value will be increased. So that will be give a line at 121. This 121 is called m plus 1 peak. And if the 122 peak also there, that is called m plus 2 peak. Means simply here you can remember this m plus 1, m plus 2 peaks comes under isotopic peaks. Means in a given molecule, any carbon or like there is a possibility of M plus 1 isotopic phase related to carbon atom, and similarly if the given molecule compound has chlorine, bromine, sulfur, these are having the isotopes having more number compared to normal one. It is more number is 2. So simply for example take chlorine molecular weight simply we can calculate as 35. Sometimes chlorine is having the isotope that is chlorine 37. If you calculate with the 35 it is a M peak. If you calculate with 37 it is M plus 2 peak. So M plus 1 peak and M plus 2 peaks are called as isotopic peaks. Okay, and one more thing here. See here these smaller lines is due to isotopes which is termed M plus 1 peak and M plus 2 peaks. Okay, carbon will be there, you will get M plus 1 peak, and chlorine, bromine or sulfur will there, you will get a M plus 2 isotopic peaks. And see, observe here, out of M by Z 120, M by Z 105, M by Z 77, M by Z 28, M by Z 15, out of these 5 peaks, M by Z 105 peak is having more intense or more tall. In your words, it is a more tall. Why we drawn here more tall means based on the stability of these fragmented ions. Based on the stability of fragmented ions, we are going to draw the intensity of the peak. If a fragmented molecule is highly stable, then it will having the high intensity peak. High intensity means this is a very taller one, then it is called base peak. Okay, base peak nothing but in a mass spectra, the peak which is having high intense peak is called as a base peak. This is due to high stability of the fragmented ion. Okay, this is about M plus 1 peak, M plus 2 peak, base peak, as well as molecular ion, daughter ion, parent ion. Parent ion also called molecular ion. One more name, parent ion also called, here I am writing, parent ion also called molecular ion. Okay, now see here, whatever the explanation I gave, I wrote here. M plus 1 peak, whenever the carbon is having C13 isotope, then you will get example in acetophenone, total molecular ion is 120, M plus 1 means 121 peak also you got that. And for example M plus 2 peak, if the chlorine, bromine will be there, sulfur will be there, you will get M plus 2 peak. Simply for example chlorine 35 generally, whenever the chlorine 37 is there, isotope is there, you will get a peak at M plus 2. So see here example methyl chloride, commonly if you take Cl35 you will get a molecular ion peak at 50. If it is a chlorine C37 will be there, you will get a peak at M plus 2, that is 52. Okay, these two are called comes under isotopic peaks. And already I explained base peak also. The most intense or tallest peak in a mass spectrum called base peak. This is due to highest stability of the fragmented ions. Example in acetophenone, M by Z 105, already I explained in acetophenone mass spectrum. And final one is about nitrogen rule. Nitrogen rule is very simple. Nitrogen rule explains that in a given molecule, okay, sample molecule has 0 or even number of nitrogens, then the M by Z value of that molecule also even. Okay, means if the nitrogens are 0 or even, then M by Z also even. If a molecule has odd number of nitrogen, then the M by Z value of the molecule also odd. This is called nitrogen rule. Okay, 0 or even number of nitrogens will be there, M by Z value also even. If the odd number of nitrogens will be there in a molecule, then M by Z value also odd. Example, see here, CH4, 0 number of nitrogen, then M by Z is even. Similarly, C6H5N2, okay, 2 nitrogens are there, means it is even, so M by Z also even number. C2H5NH2 ethylamine, only 1 nitrogen is there, so M by Z value also odd. Ammonia, nitrogen is in odd number, so M by Z also odd. This is about nitrogen rule. Okay, thank you.